Welcome to The Explainer, where we break down big topics into clear, understandable insights. Today, we're cracking the code on the revolutionary technology that everyone is talking about: large language models.
I mean, you've probably seen the magic yourself. AI is out there writing poems, solving really tricky math problems, even generating computer code. It's wild. But have you ever stopped and wondered, how does it actually work? What's going on under the hood that allows a machine to be so versatile, to be good at both, art and logic?
Well, believe it or not, this entire incredible revolution, it all starts with one surprisingly simple trick. Seriously, it's a single idea, and it's the foundation for everything we're about to cover.
Okay, so let's dive right into this core idea. What we're talking about, at its heart, is basically autocomplete. Like on your phone, but on steroids. A lot of steroids.
Yep, that's it. At their core, these language models, or LLMs, are trained to do just one thing: predict the next word in a sequence. Every single amazing thing they do, from writing poetry to solving math problems, it all flows from this one simple fundamental skill. Now, what's really cool is seeing how this simple idea has evolved. We've gone from what we used to call pre-trained language models, or PLMs, to the large language models, LLMs, that are making all the headlines today. And the biggest difference between them is, well, it's about what they're built to do.
So think about it this way. An older model, like the famous BERT, was kind of like a specialized tool in a toolbox. You'd train it on tons of text, but then you'd have to fine-tune it for one specific job, like figuring out if a movie review is positive or negative. Modern LLMs like GPT-4 are completely different. They're like a multi-purpose Swiss Army knife right out of the box. They can tackle a huge variety of tasks without needing any of that special one-off training.
So the big question is, what caused this huge leap? Was it some brand new genius algorithm? Nope. The secret ingredient was just scale. And when I say scale, I mean a dramatic increase in scale.
See, here's the thing. As these models get bigger and you train them on more and more data, something almost magical starts to happen. They suddenly develop new skills that nobody explicitly programmed into them. Researchers call these emergent abilities, and they are a total game changer.
And this chart is a fantastic example of what I mean. Look at the line for arithmetic. For the smaller models, performance is basically flat. It's at 0. The model just can't do it. But then, once the model hits a certain size, bam, the performance just shoots up out of nowhere. It's incredible. The model wasn't taught math, but by getting really good at predicting the next word, it somehow learned how to reason arithmetically.
So yeah, that brings up the key question, right? If it's really just a super advanced autocomplete, how in the world does a word predictor solve a math problem? How does that even work?
Well, one of the most fascinating emergent abilities that helps explain this is something called chain of thought prompting. It's exactly what it sounds like. The model basically learns to think out loud. Instead of just spitting out a final answer, it realizes that the most probable path to a correct answer is to first write out the step-by-step reasoning, just like you would on a math test. And this simple trick, just thinking step by step, massively improves its ability to solve complex problems. And look, this whole thing wasn't just surprising to us regular folks. It caught top researchers completely off guard. You've got Percy Lang from Stanford here saying it was just eye-opening that you could train a model to do one simple thing, predict the next word, and suddenly it can summarize documents, have conversations, translate languages. It just goes to show how powerful and honestly, how unpredictable this whole emergence thing is. Okay, so that's the what behind these models. Now let's pull back the curtain and look at the how. Let's take a little trip to the factory floor and see how these digital brains are actually built.
Building a top-tier LLM is, as you can imagine, a massive undertaking, but we can really break it down into 3 main stages. It starts with data preparation, then moves to the big one, pre-training, and finishes with fine-tuning and alignment.
All right, step 1, data. It all begins with data, and we're talking about an absolutely colossal amount. We're talking trillions of words scraped from the internet, from books, from code, and it's not just about collecting it. It's about cleaning it and preparing it. This first step is so important.
Then comes the second stage, pre-training. And this is the really expensive part. I mean, we're talking millions of dollars in computing power. The model basically gets locked in a digital room with all that data and does one thing, over and over and over. It just predicts the next word. And by doing this billions of times, it starts to absorb everything: grammar, facts about the world, and even the basics of reasoning. Okay, but that raw model isn't quite ready for prime time. That brings us to the final step, fine-tuning and alignment. This is where humans come in. They basically act as coaches. They'll give the model a prompt, look at several of its answers, and then rank them from best to worst. This process, called reinforcement learning from human feedback, or RLHF, teaches the model to be more helpful, to follow instructions, and importantly, to be safe. It's what turns a raw text predictor into a helpful assistant.
All right, so now we know how they're built. Let's take a quick tour of the zoo. Let's meet some of the different LLM families and see how they're designed.
So the LLM world is pretty much dominated by a few major families. You've got OpenAI's GPT models, of course, then there's Meta's LLaMA family, which has really energized the open source community, and of course Google has its own powerful models, like Palm and Gemini. Each of these families has its own kind of lineage, its own strengths and weaknesses.
And if you look under the hood, you'll find there are a few core architectural blueprints. The one you're probably most familiar with is decoder-only, used by models like GPT and LLaMA. Think of them as storytellers. They read from left to right, always predicting what comes next, which makes them awesome for chatbots and text generation. Then you have encoder-only models, like BERT. They're more like editors. They look at the whole sentence at once, both forwards and backwards, which makes them really good at understanding context for tasks like classification. And finally, you have encoder-decoder models, which are a bit of both. They're the natural-born translators, perfect for mapping one sequence to another, like translating English to French.
Okay, so things are moving at a breathtaking pace. So, to wrap up, let's talk about what's next. Where is this new frontier heading?
A huge focus right now is connecting these LLMs to the outside world, to get them out of their own heads, so to speak. One way is through something called Retrieval Augmented Generation, or RAG, which is a fancy way of saying we're giving the model access to external knowledge, like real-time information. Another big push is giving them tools, literally connecting them to things like calculators or flight booking systems so they can not only talk but also do things. But of course, as these models get more and more capable, the challenge of deploying them responsibly becomes absolutely crucial. We're talking about really tough problems here. We need to make them more reliable and reduce what people call hallucinations, when they just make stuff up. We have to tackle bias, ensure accountability, protect user privacy, and make them secure. This whole area of responsible AI is probably the most important work happening in the field right now. And that really leaves us with this final big question. We've cracked the code. We've taught machines how to talk. So the question isn't a technical one anymore, it's a human one. What should we ask them to do? And maybe more importantly, what rules should they and we follow? That's the conversation that's just getting started.